Hello everyone, in this video we are going to learn about parallel and perpendicular lines. So for this lesson we aim to know the gradient condition for two straight lines to be parallel or perpendicular. So for two lines that are parallel, which means they have the same gradient. Well, for the two lines that are perpendicular to each other, in other words, at right angles to each other, that we see if L1 has a gradient of m, a line L2 perpendicular to it has a gradient of -1 over m, which means if two lines are perpendicular, the product of their gradients is -1. Now let's see an example question. So there is a line L1 has equation 4x plus 5y minus 3 equals to 0 and crosses the y-axis at A. The L2 is perpendicular to L1 and passes through A. L3 is parallel to L2 and passes through -3, 1. Part A, it asks you to find the coordinates of the point A. So how do we find point A? We notice that A is a point that L1 crosses the y-axis. So L1 crosses the y-axis at A, which means x equals to 0. So for x equals to 0, we need to find the y coordinate. So we substitute x equals to 0 into the equation. 4 times 0 plus 5y minus 3 equals to 0. We left y equals to 3 over 5. So the point A is 0, 3 over 5. Now for part B, the question asks you to find the equation of L2 and L3 and in the form ax plus by plus c equals to 0. So let's see what the question talk about. We know that L2 is perpendicular to L1. So when L2 perpendicular to L1, which means the product of their gradients is -1. So firstly, we need to find the gradient of L2. And if we want to find the gradient of L2, we need to find the gradient of L1 from the equation 4x plus 5y minus 3 equals to 0, right in the form y equals to mx plus c. But we have 5y equals to minus 4x plus 3. So y equals to minus 4 over 5x plus 3 over 5. Then we have the gradient m1 of the line L1 is minus 4 over 5. In this case, we can get the gradient m2 of L2. That is -1 divided by minus 4 over 5 equals to 5 over 4. So that equals to that is M2. We know the gradient of L2, then we can write L2 as y equals to 5 over 4x plus C2. Then we need to find the constant, that is y-intercept of L2. We know that L2 passes through point A, so we can substitute x-coordinate and the y-coordinate of A into the equation L2. From part A, we know A is a point 0, 3 over 5. So we substitute it into L2 equation. That is 3 over 5 equal to 5 over 4 times 0 plus C2, which means C2 equals to 3 over 5. Overall, L2 has an equation y equals to 5 over 4x plus 3 over 5. Well, the question asks you to write your answer in the form ax plus by plus c equals to 0. Then we need to times 20 on the both hand sides, the smallest common multiple. So we have 20y equals to 25x plus 12. So we have minus L2 is the equation minus 25x plus 20y minus 12 equals to 0. Now we got the equation L2. And also the question asks you to find the equation of L3. We know that L3 is parallel to L2. So L3 is parallel to L2, which means the gradients of them are the same. So that the gradient, we call that M3 of equation L3 equals to M2 of L2. So M3 equals to 5 over 4. So we have L3 in the equation, in the form of equation y equals to 5 over 4x plus C3. And also the question said that L3 passes through minus 3, 1. So we can substitute the x-coordinate and the y-coordinate into the equation of L3. Substitute minus 3, 1 into equation of L3 to find the value of C3. So we have 1 equals to 5 over 4 times minus 3 plus C3. So we get 1 equals to minus 15 over 4 plus C3. So C3 equals to 19 over 4. Thus, we get the equation of L3, that is y equals to 5 over 4x plus 19 over 4. Also, the question asks you to write in the form ax plus by plus c equals to 0. So we need to times the lowest common multiple, that is 4, on the both hand side. We have 4y times 5x plus 19. And we rearrange that, we have L3, that is minus 5x plus 4y minus 19 equals to 0. So we get the equation of L3. Now we have done the question of that. The main thing for this lesson is this part. You need to remember that two lines are parallel, which means they have the same gradient. And if two lines are perpendicular to each other, the product of their gradients is -1. Thank you for watching.